Hi everyone. I am tasked to discuss about one-way repeated measures ANOVA using JASP and post-hook analysis. Repeated measures one-way ANOVA is used to determine if there is a significant difference between the means of three or more groups in which the same subjects show up in each group. For example, if you want to identify or if you want to determine if there is a significant difference between the ratings of five individuals to the three movies they watch, or another example, if you want to determine if there is a significant difference between the heart rate of 10 athletes to the four programs you have given. So for now, let me share my screen so that I can show you on how to use um, one-way repeated measures ANOVA using JES. The first thing to do, if you don't have the file in JESP, you need to input the data in the Excel. And after you input the data, for example, you have here student 1 to 10. So there are 10 subjects or 10 students. And then we have here three review methods. So these 10 students were exposed to the three review methods, and we will identify or determine if there is a significant difference between the three review methods. After you input the data in Excel, you need to save this one in CSV form. So after you save this one, you will go to JESP, and then you will click open and look for that file. So you have here the three review methods. After you input your data in JESP, you need to click ANOVA and click repeated measures ANOVA. Again, you will click ANOVA, then click repeated measures ANOVA. After you click repeated measures ANOVA, you have here the first one, the repeated measures factors. So the repeated measures factors here are the review methods. So let me click here, review methods. Then you will type here method 1, method 2, then you'll have here method 3. After you input those names, it will appear here in repeated measure cells. And all you need to do is to input this data here. Just click this, click, and click. After you input those data here or cells, it will appear the result at the right side. So you have here the results. You have the result for repeated measures ANOVA. So the most important thing here is the p-value. We also have the sum of squares, the degrees of freedom. We also have the mean square, the f value, and we have here the p-value. And we will be using this p-value to identify if there is a significant difference between the three review methods. So since the p-value here is 0.003, which is less than the level of significance 0.05, then we can say that there is a significant difference between the three review methods. Since there is a significant difference, we now proceed to the post-hook test. So just scroll down, look for post-hook test. Then you have here review methods, just click this. And after you click, you have here options for the correction, home correction, Bonferroni correction, Tukey, or Shippy. But for this one, you can click here Bonferroni since the Bonferroni correction is more familiar for me. So after you click here Bonferroni correction, you will have this one. So we have here method 1 versus method 2. The p-value here is 0.004, so we can say that there is a significant difference between method 1 and 2. And to identify which one is better, we need to click descriptive statistics so we can compare the means. So for method 1, we have here 84.8, then method 2, we have 89.3. Since there is a difference between the two, we can say that method 2 is better than method 1. And we also have here method 1 versus method 3. And as seen on the result, we have here p-value 1.0, which indicates that there is no significant difference between method 1 and 3. And for method 2 versus method 3, we have here 0.020 as the p-value. So we can say that there is a significant difference between method 2 and method 3. So we can say now that method 2 is better than method 3. As we can observe here, the mean of method 2 is greater than the method 3 and as well as the standard deviations. So that's how to do um, repeated measures for the first example. Let's have here another example. Let me just open JSP again. And then click this one. You click open. I already prepared another file for the next example. So for example, another example, we have here 10 subjects. And then these 10 subjects shows in each of these days. So you have 10 subjects in day 1, the same subjects in day 2 up to day 5. And our task is to determine if there is a significant difference between the 5 days. First thing to do is to click ANOVA, click repeated measures ANOVA, and we have here the repeated measures factors. So let me just write your time or day. It's up to you. How will you label the repeated measures factors? So you have your day 1, day 2, day 3, day 4, day 5. Then lastly is, yeah, you have your day 5. And after that, you will put here day 1 beside day 1. Then for day 2, day 3, day 4, and day 5. All you need to do is to click this arrow. After that one, you will look for the result. So we have here p-value is less than 0.001. So it is less than 0.05, which indicates that there is a significant difference between the 5 days. There is a note here that um, test of sphericity indicates that assumption of sphericity is violated, and based on the video, YouTube video given by Dr. K, it was said that you need to click this one, assumption checks, and you will click greenhouse geyser or geyser. Okay, after you click that, you will go back here, and there is a little difference between the result. So you have here the p-value is 0.001 and which is less than 0.05. So we can say that there is a significant difference between the 5 days. And since there is a significant difference, you will go back to the tool, and then you will click here, post hook test, click time, then click this arrow. After you click this arrow, you have here options on what post hook test that you will use. So for me, I'll use here Bonferroni correction, and then let me also click the descriptive statistics so I can compare the 5 days. So after that, you have here the result for the post hoc test. You have here for day 1 versus day 2, we have to 1.0, which is greater than 0.05. So there is no significant difference between day 1 and day 2. For day 1 versus day 3, day 1 versus day 4, and day 1 versus day 5, we can say that there is a significant difference between them since their p-value is less than 0.05. For day 2 versus day 3, there is no significant difference since the p-value is 0.0643, which is greater than 0.05. Day 2 versus day 4 and day 2 versus day 5, we can say that there is a significant difference between them since their p-value is less than 0.05. For day 3 versus day 4, there is no significant difference since the p-value is 0.232. And for day 3 versus day 5, there is a significant difference since the p-value is less than 0.05. And for day 4 versus day 5, we can say that there is no significant difference since the p-value under Bonferroni correction, it is 0.210, which is greater than 0.05. Okay, so that is for the second example. And for the last example, let me click this one. This is a data from the JESP itself. So based on the problem, we have here eight celebrities, and then we have here 4 different foods. So these are exotic foods. And the numbers here, 8, 9, 6, 7, 5, 2, 1, 2, 3, 6, 5, 8, and so on. These are the number of seconds where these celebrities range after eating or during eating these exotic foods. And to identify if there is a difference or significant difference between the 4 types of foods, you need to click ANOVA. Repeated measures ANOVA. And the same thing, we have here the types of foods. We have here the stick, insect, kangaroo, testicle, fish eye, and then lastly, the witch city crab. Okay. After typing that, you need to click this stick insect, then click this arrow to the right, and that one, this one also. After that, you click here the descriptive statistics, and based on the result, you have here this one within subject effects. The p-value here is 0.026, which is less than 0.05, which indicates that there is a significant difference between the 4 types of foods. And since there is a significant difference, we now proceed to post hoc analysis. So just scroll down, click post hoc test. You click this type of foods, and then click this arrow to the right. Then you pick here. It's up to you. For me, let me pick here Bonferroni, and then go to the result. And based on the results, you have here stick and sick versus kangaroo testicle. The p-value here is 0.055, which is greater than the level greater than 0.05, which means that there is no significant difference between the number of seconds um, in eating stuck insect and kangaroo testicle. And for fish eye, the p-value here is 0.045, which means that there is a significant difference between the two. And since there is a significant difference, we now look to the descriptives and we compare the means of stick insect and the fish eye. Okay, so for the fish eye, we have 4.125, and while for stick insect, we have 8.125 seconds. And for stick insect versus the witch chitic grub, the p-value here is 0.560, which is greater than 0.05. So we can see that there is no significant difference between the two. And for the kangaroo testicle versus fish eye, and also for the kangaroo testicle versus Tukey grub, the p-values here are greater than 0.05, which indicates that there is no significant difference between them. And lastly, the fish eye versus the witchetty grub, the p-value here is 1, which is greater than 0.05, so we can say that there is no significant difference between them. Okay, and so that's how to use JASP on determining the difference between three or more groups in which the subjects shows or show up in each of the group. That's all, and thank you.